Good morning.
Hi, Rory. Are you all right?
I am, thank you. And good morning or good afternoon to you.
Indeed, indeed. Yeah.
Hi, Mark.
Okay, Rory, you're okay?
Yeah, not too bad.
Okay,
Apologies,
we're
I've got.
okay. Are you okay to start? Shall we go for it?
Yeah, absolutely.
Okay. Right. Good afternoon, everybody, and hopefully most of you are in the same time zone as us. But for some of those who are abroad, and there's a few names I recognise from being abroad, good morning to you. My name is Mark Orr, and I'm the Executive Director of the UK and Ireland Spill Association. I'm going to be acting as the host for this webinar and will introduce RSK Raw, who will be delivering the keynote section of the webinar. So I'm not going to steal their thunder there. And I think they've got a very interesting case study of a spill that they've dealt with, which involved remediation and liaison with regulators and that sort of stuff. So I think that'll be very interesting. If I can just, most of you have obviously done webinars before because your cameras are off and most of you are muted. At the end, there will be, if you have a question that you want to ask, please use the chat facility, and then and I will pick those questions up at the end, and I'll unmute everybody so that they can ask the questions, and hopefully there'll be a good exchange of questions, and Rory can answer them, or other members of our committee who are on the call can answer. So please do interact. So you may have noticed since our last webinar that we're now the UK and Ireland Spill Association. Last month, with the support of our members, UK Spill merged with International Spill Accreditation Association to form the UK and Ireland Spill Association. Now united, we're able to speak with one voice on behalf of our members, on behalf of the industry, and do all we can as one body to support government, regulators, regional and local authorities, and of course the spill and incident response organisations who are our members across now the UK and the Republic of Ireland. So we now provide one point of contact for all who require information on spill and incident response, provide the ability to access member networks to cover surges in demand for major incidents, provide the ability to work with other trade associations as the sole voice for the spill and incident response industry in the UK and the Republic of Ireland. And of course, we do all we can to represent our members wherever they are in the UK, Republic of Ireland, but also to those members who are overseas. So the merger has enabled us to start to take the best of both established accreditation schemes, and we're in the process of creating one set of inland, shoreline and marine accreditation schemes for our members that comply with current legislation within the UK and Republic of Ireland, and of course within the EU, and represent the implementation of best practice across the industry. So these are managed through our accreditation body, International Spill Accreditation Scheme Limited. Now this was already established, and it was what UK Spill was using prior to establishing, prior to the merger. But this now creates a separate business, which is dedicated to raising standards and running a robust accreditation scheme that now includes training. So like UK and Ireland Spill Association, ISAS has its own board, which Stuart Ower is chair of, and has people of real significance within the industry as board members. And obviously a key role for ISAS is to produce best practice guidance that can be disseminated with authority. And I think people who look at our board members will see that that's certainly the case. We have a lot of talent within both boards, but I'm delighted that International Spill Accreditation Scheme Limited has such a strong board. So what has been happening in the spill and incident response community of late? Well, all members that I speak with have been really busy, and it's been great. There's been a lot of activity going on. Most have retained work throughout lockdown. Most have retained all of their staff through lockdown, and they've all been working as key workers. There have been a higher than usual number of domestic and industrial fuel tank failures, These have been both steel and plastic tanks, with the resulting loss of product that has required cleaning up. The increase in spills has been significant, up around 40 to 50% on annual average. That is significant in itself. Now, the root causes have been, as we went into lockdown, I think everyone, and I'm a householder who has an oil tank, we all filled our tanks up. As we approached or started to go into lockdown, or early in lockdown, people filled their tanks up, not knowing how long lockdown would last. It was then very warm, which was great for the UK and unusual. So tanks product in the tanks expanded, and then it became wet and cool. And so products in the tanks contracted, and so did the tanks. And I think lots of systems were working much harder than usual because families were at home throughout. So all I would say is that there's been lots of incidents. But if you have a heating oil tank, we would strongly urge everyone who's got an above ground tank, whether domestic or industrial, to make sure that the tank insulation isn't becoming overgrown with vegetation that would hide the condition of the tank. Check the tank base or its supports for cracking or subsidence. Ensure the tank has a working contents gauge, and if it has a valve system, make sure the valve is closed. Check all visible pipework, valves and filters for damage and signs of leaks, such as dampness or staining, especially around joints. Check vegetation around the tank for signs of dieback, because that's really an early indication of a leak. Check any secondary containment that you've got and clear it of rubbish or liquid before the winter rains come. Although in my case, I look out the window now, there's plenty of rain out there at the moment. If you have drip trays, check that they are empty and haven't got oil and water in them. If you have a plastic tank, do have a really good inspection of the tank. And if you see any whitening or cracking or splits in the plastic, any bulging or deformation of the tank profile, then consider replacing the tank, but at least talk with an Offtech engineer or with a spill response company to make sure that you get it changed before winter. And if you have a metal tank and there's significant rusting or on the tank, clear the metal off. Check that the tank's condition underneath the flaking of the paste, of the flaking and of the rust and on the paint. And if you start seeing dampness on any seams or welds, then the tank needs replacing. So once you've done all this and you've checked that your tank is in good condition, then fill it up. Don't top it up until you're happy. And during the winter, check your tank monthly. Keep vegetation clear of it so you can easily see if something is going wrong, and do what you can to protect it from falling trees, particularly this weekend where in England it's going to be very windy. And while you're doing all that, it's worth checking your home insurance policy to make sure that it includes cover in the event of a tank failure, both to clean up the spillage, but also to replace the tank and its contents, which obviously once you fill it up are quite valuable. So, other things, we were delighted to read the recently introduced guide issued by the Environment Agency and DEFRA on land contamination risk management. So the EAS has addressed extensive feedback on the technical content and on the structure of land contamination risk management. There was a lot of feedback on the usability of the current setting for it on .gov.uk. But they are quite adamant that it will only be published on gov.uk. But there will be 4 HTML guides which go with it, and they will be frequently updated. Now, the reporting requirement checklists are included within the guidance, but you have to get to the end of each stage to find the checklists. Now, the site investigation section is now an integral part of the risk assessment guide. And in general, what they're encouraging you to do is to download the guides and, if necessary, print them or at least save them as PDFs so you can keep them on your file. But actually keep checking the updates, because as there is more feedback, there will be more updates. And as you deliver feedback, please make sure that you're clear in what your feedback is, and email it to groundwater.inquiries@environment-agency.gov.uk. I think we see this as a positive step forward, and I think it's really good to see CLR 11 being replaced now with LCRM, and I think this will become the way that these things are managed in the future. We will do at some point a webinar under ISAS, which will specifically address land contamination risk management going forward. But I think that's a positive step forward. Okay, now some of you who follow LinkedIn and are probably in the industry will be aware that there was a major incident at Llangennych involving a train which was travelling from Puma Energy's terminal in Milford Haven to Puma Energy's site in Theale in Reading. So every day a locomotive similar to the one on the screen pulls up to 30 railway tank wagons loaded with fuel from Puma Energy's terminal in Milford Haven to either its two regional inland terminals, either at Wesley near Bristol or Theale in Reading. Now, each of these wagons carry around 80,000 litres of fuel, and the fuel being moved from the terminal in Milford Haven is either diesel, petrol, kerosene or aviation fuel. Now, this is not unusual. This is not an unusual practice, and it goes on, and most fuel is moved from terminals to inland sites by rail. And there are some 800 railway tank wagons which operate safely daily on the UK rail network. Bear in mind that each wagon generally saves three tankers being on the road, and it's a safer and more environmentally sustainable way of moving bulk fuel quickly and efficiently around the country. However, at 23:15 hours on the 26th of August, this freight service conveying 25 wagons, each containing around 75 to 80,000 litres of 75 to 80,000 tonnes of diesel or gas oil, derailed near Llangennych in Carmarthenshire. The derailment and the subsequent damage to the wagons resulted in a significant spillage of fuel and a major fire, which people in that locale could see. The driver, who was unhurt, reported the incident to the signaller and closed the line. Subsequent examination of the site revealed that a total of 10 wagons, the 3rd to the 12th, in the train had derailed, and that around 330,000 litres of fuel had been spilled. The fire was tackled by the fire service, who ordered the evacuation of local residents due to concern for their safety. And local people have reported seeing the picture that I've got on the screen, a plume of flames and smoke and a very, very strong smell of fuel. Now, immediate response was provided by Adrian Allen, who were appointed by Puma Energy as their spill responders for the incident. And they had some assistance from Ambipar and OSRL, particularly related to the impact that the fuel had on the estuary. And you can see a tributary or a pond which leads into the estuary in the picture on the screen. Now, as this was a major instance, CFAS were employed and have assisted. And they were employed particularly by the Food Standards Agency to monitor the impact that the spill may have had on the shellfish which are in the estuary. Now, the pictures from the scene were startling, and this was one of the images taken a couple of days later when it was safe to get close to the railway wagons. Now, obviously, the fire, which occurred immediately, and then continued really for the most of the following day, prevented any access to the spilled site because of the risk of the further explosions or further fire being caused by the fuel that was being retained in the wagons. And there was extensive cooling of the railway wagons being done by the fire service. The fire is estimated to have consumed 116,000 litres of diesel. And of course, as I've already said, some 330,000 litres was spilled. Now also, and having been involved in derailments of railway tank wagons before, these are large, powerful beasts. I mean, they're roughly, they're nearly 20 meters, they're over 20 meters long, they're big, they're heavy things. They are quite unstable when they derail, and you can see they're round. And so to actually approach them and deal with removing fuel from them, you have to have a declaration from either the rail freight company who run them, or you have to have the Rail Accident Investigation Board certify that it's safe to approach the wagon. In other words, that it's stable. And so quite a delay was occurred in dealing with the incident, being close up to the incident, purely because the instability of so many of these wagons, such that they couldn't then be approached to gain access to them to remove their contents. And of course, they stayed hot for quite a long time. So access to the site was constrained. But what it did do, unfortunately, was because it couldn't be controlled, fuel went into the regional estuary. And the black and the red dots on this estuary, the rail line I've highlighted, and you can see that it runs very, very close to the edge of the estuary up in the top left-hand corner of your screen. And you can see I've highlighted the railway line there, so you can see where it runs through. Now, obviously, some of this fuel regrettably got into the estuary, and you can see, and that is a really sensitive estuary with a lot of wildlife and a lot of diversity. And whilst everything was done to prevent the fuel getting into the estuary, some fuel did escape. And part of the responders' job, particularly Ambipar OSRL with Adrenaline, were to try and identify where it had gone in the estuary. And this gives the green spots show that it was absent, but the red spots show where diesel was present. However, once safe access to the site was possible, the priority was to offload the remaining fuel, and that all happened fairly quickly, with some 400,000 litres of fuel was removed by the 1st of September. All 8 wagons were removed by the 8th of September, enabling complete access to the site. This also then enabled the fuel, the track and rail infrastructure to be removed, and significant contaminated ballast and soil removal of site has taken place, and in the surrounding area to the site. And also there's been quite extensive collection of product from local streams and in the ditches as it has been washed out of the ballast and washed out of the siding into the area surrounding it. And these are some pictures of what's been done, including this bubble boom, which has been used, with several bubble booms have been used as they help in collecting the product from the streams and the ditches. Work is likely to continue for some time, and the rail infrastructure has yet to be reinstated, and the line has been reopened. Now, obviously, in any derailment, the Rail Accident Investigation Board are involved, and their preliminary examination has found that although the wheels of the train were probably rotating freely when the train left Milford Haven, at some point during the journey, the brakes on all wheels of the 3rd wagon in the train had become applied and remained so until the derailment. The lead axle ceased to rotate altogether. This is on wagon number 3, and consequently a flat spot of around 230 millimeters long, and you can see it on this picture. This 230 millimeter long flat spot developed on each side of the wheels on this axle. There was a substantial false flange, in other words, a raised lip on the outer side of the wheel tread, which is associated with these flat spots. And you can see this quite clearly through this picture. So when the train reached the crossover at Morlaye Junction, travelling at about 30 miles per hour, 48 kilometres an hour, the false flange on the right-hand wheel caught on the converging stock rail and distorted the track, which then led to the derailment of both wheels. Around 100 metres further on, the partially derailed wagon encountered facing points set to route the train to the right. The locomotive of the two leading wagons went to the right, and the derailed third wagon then went straight ahead. And the third wagon turned over on its right-hand side, became detached from the wagon in front of it, and this caused the points and the track beyond them to be destroyed, and the derailment of another 9 wagons followed. Now, once it had broken the connection with the wagons in front of it, those wagons then came to a stop some 180 meters away from the third wagon. And when the 12th wagon had derailed, it broke its connection, which applied the brakes to the wagons which were behind it. So obviously the Rail Accident Investigation Board have issued preliminary findings. It's quite hard now to get detailed information about the spillage and its consequences. Presumably, because it's such a large spill, there's an equally large bill to be paid, and whoever is being found, and obviously there's a bit of a lockdown and information coming from it. With the issue being the brakes, it could imply that it is the maintainer of the wagons, but these are who is at fault. But these are early days, and these investigations will have some time to progress until we find out, until our AIB decide who was at fault. But in the meantime, the work continues, and there's a lot of work going on, and we will only get an indication that things are drawing to a conclusion once the rail infrastructure is back on the tracks and the line reopens. In the future, I'm sure it will make a very interesting case study, but do watch out on LinkedIn for news as it emerges. So hopefully that sets the scene of some of the things which have been catching our eye at UK and Ireland Spill Association. So I'd like to introduce corporate and accredited member RSK Raw, who are going to introduce a very interesting case study involving herbicides. Now, if you have any questions, please use the chat facility to send them to me, and then I'll introduce you and you can pose questions, and I'll ensure that your mute buttons are off. So what I'm going to do now is I'm going to stop sharing my screen. Rory's going to share his screen, and he will get on with the presentation. So there'll be about 30 seconds disruption while we do that. Rory, over to you.
Thank you, Mark. Can you just allow me to share my screen, please?
Oh yeah, of course, yeah.
Thank you.
Okay, that should be enabled now.
Brilliant. Can you see that?
Yeah, and if you just go slideshow.
There we are.
Great.
Lovely. Thank you very much. And thank you for the introduction. Thank you also for the opportunity to speak today and to be part of the UK and Ireland Association webinar. And for those of you that don't know me, I was appointed to the board of the association a few weeks ago to represent the Inland Spill and Consultancy position. I thought it would be a good idea to use today to explain maybe how the consultancy part of the role can become such a big part of a spill cleanup. Now, this is only a short presentation, but I thought a quick summary about the background of technical specialists would be useful, followed by a bit more information about different spills, and then go straight into a case study that shows the type of incidents that are becoming much more common for us, RSK Raw. If you go back a few years when the inland spill industry was in its infancy, there were basically 3 options for many operators, landowners or insurers when they had a spill. They could have sorted it out themselves, which may have resulted in them doing nothing, making it worse, or putting their employees at an unacceptable risk. Failing that, they often had a choice of contacting a contractor or consultant. I'm basing this on many preconceptions rather than fact. It was originally thought that a contractor would mobilise the site, jump in with both feet and excavate large unnecessary areas, or send in fleets of tankers all at the client's expense with little justification. The alternative was to appoint a consultant, but the average factory operator at the time would believe all they get is lengthy reports and very little action. This has led to the rise of technical specialists that combine the best parts of the contractor and consultant to produce a product more worthwhile to the client. Many of these technical specialists, RSK Roy included, could provide a response to small spills such as heating oil and onto larger commercial incidents. The approach to contamination has become more technical through the years, and the services have been developed to provide a wider range of products to clients. However, I don't think industry has been particularly good at explaining how complicated some of the work is, and in some areas, this has resulted in the work being commoditized and undervalued. We're frequently contacted, and it's assumed all we do is place booms across watercourses and place absorbents down. We're constantly asked to provide proposals for oil spills, as if that's the only thing a company is likely to spill. There needs to be a reality check. We all know that oils generally exhibit non-polar properties and don't mix well with water, but it's often forgotten that other potential pollutants such as herbicides and milk exhibit polar properties and will mix well with water, whether by solubility, suspension, or colloidal liquids. These pollutants cannot be cleaned up using booms and absorbents, and it's essential that we and our clients understand the properties of these pollutants. Understanding how a pollutant will interact with the environment is essential, or is as essential as understanding the site geology, hydrogeology, and hydrology. It's also worth noting that spills don't only impact watercourses, but we have to assess the damage to a wide range of receptors, often including groundwater, buildings and services, and people. Everybody here today should know what a precious resource our groundwater is, but it often comes as a surprise to our customers when we explain to them that 1/3 of our drinking water supply comes from groundwater, and that is why the regulators are so precious over it. There's also a wide range of additional services that are required these days in connection with spills, some of which are regulatory, such as asbestos and ecology, and others to help further understand the spill. We are lucky now, as part of RSK, to have these services in-house. Anyway, to the incident. Whilst a crop sprayer was being towed through a farmyard, a failure of a hydraulic steering hose resulted in the sprayer striking a gate and overturning. This resulted in at least 1,000 litres of an aqueous solution being lost to ground. The solution was reported by the farmer to be a herbicide mixture. Initial death study research undertaken identified that a principal aquifer underlay the site, although it did not appear to be within a source protection zone. It was also observed that adjacent farms had abstraction boreholes, primarily for recharging animal troughs, but they were located over 600 metres from the spill incident site, and it was initially thought unlikely that they'd be impacted by the spill. Soon following the spill, an area of grass dieback had been observed some 500 metres away from the source area. Nothing similar had been observed closer to the spill origin. The Environment Agency was also undertaking groundwater monitoring and sampling of the abstraction boreholes near the area of dieback, and laboratory analysis of the water sample showed that the presence of linearin, you have to excuse my pronunciation of these, linearin and the metribuzin, both of which were herbicides that were in use at the time. I don't think it's possible to purchase linearin any longer as it's since been withdrawn. But anyway, this was a heavily farmed area, so it was too soon to draw conclusions as to where this contamination had originated. Investigation was required. The farmer provided information on the contents of the sprayer after the unfortunate incident resulting in its rollover. This indicated that the sprayer contained a mixture of prosulfocarb, an emulsifiable concentrate, metribuzin, held in a colloidal suspension, and linearin, which would have been crystals with a slight solubility held in suspension. The contents of the sprayer did appear to contain similar herbicides to those found in the abstraction boreholes, some 600 meters from the spill origin. It's worth noting on this plan the land drains and an open ditch that flows southerly from the spill origin. The second stretch of land drain was noted to be in close proximity to the area of dieback, and therefore it was possible that this was related to the spill. Research had already shown that the abstraction boreholes were pumping from a deeper aquifer, and therefore the linkage had not been identified. Response. Clearly, given the type of pollutant, traditional spill response equipment such as booms and absorbents were not going to work. However, the first mitigation measures required the area of the yard where the spillage occurred to be excavated. You can never quite get away from excavation. The material in this area was saturated, and it was essential to remove it as soon as possible. And the worst of the material was limited to an isolated area, as you can see in some of the photos there. It was likely this saturated material was leaching into the drainage system around the yard, and consequently, it was essential to gain an understanding of the drainage. If possible, it was necessary to stop the contaminated water leaving site and identify where it could be recovered through pumping. The ground investigation then needed to be split into two parts. One for the shallow materials, generally in the vicinity of the farmyard, and the other for the deeper investigation of the principal aquifer, to both investigate the extent of contamination and gain an understanding on how the contamination has migrated into the aquifer. The investigation was progressed at different times over a long period of time as the understanding of the pathways and migration of the pollutant developed. For a relatively low volume of herbicide to have been lost, there was extensive contamination of the shallow materials beneath the yard. This was finding its way into the drainage system and migrating rapidly away from the yard in a southerly direction. Both the land in the surrounding area, the drainage, and groundwater had a gradient down to the south. The drainage in the area drained through a series of land drains and ditches to a pond approximately 600 meters to the south of the spill site. On analysis of the water samples, the deeper boreholes did confirm the presence of herbicide contamination in the principal aquifer, and that was of a similar type to that found in the shallow water at the spill origin. All the drilling work had to be undertaken with great care. For the shallow investigation, it was important not to investigate too deep and risk penetrating the principal aquifer. Similarly, when investigating the deeper principal aquifer, it was essential not to introduce a contaminant preferential pathway and risk causing a further pollution incident. Given the risk to the aquifer and the risk from hazardous herbicide compounds, all the work came under the scrutiny of the Environment Agency. The investigation identified a number of pathways. The yard area was immediately underlain by firm clay, and this prevented the herbicide migrating downwards, and it therefore quickly flowed towards the drain. The drain acted as a preferential pathway, and the herbicide rapidly migrated south. However, during the investigation of the drainage, it became apparent that there were a number of fractures in the drain. And as the drain traverses the field away from the yard, the firm clay aquiclude reduces rapidly, leaving behind only glacial till, sands and gravels of a secondary A aquifer overlying the Sherwood sandstone principal aquifer. It became obvious during the course of the work that the leaking drainage and drainage ditch migrated down into or allowed the contaminant to migrate down into the principal aquifer and was a potential pathway. Not all the boreholes are shown on this cross section, but you can see in the vicinity of MW2, and I hope everybody can see this plan and it's visible. Some 300 meters away from the spill site, we had identified the herbicides in the deeper aquifer. So the spill origin, as you see over here, drainage has allowed the contaminant to migrate rapidly across, and as the clay reduces, we've got this contaminant migrating vertically down into the underlying principal aquifer. Ground conditions generally across the area made access and drilling very difficult, and generally there was a lot of standing water. The photographs here, you can see in the vicinity, or the top one here on the left, you can see in the vicinity of an abstraction borehole used to feed the cattle, and it had already been identified as contaminated by the Environment Agency. Drilling works were carried out by Geocore, whom have now just joined us at RSK to help boost our capabilities. Again, more photos of the challenging access conditions and the extensive drilling work that were required for the monitoring. It's worth stating again that the Environment Agency were taking this incident very seriously and were looking for a very detailed understanding of our conceptual site model. Anybody who's worked on farms will tell you that cows are some of the most friendly animals, but they're also extremely inquisitive, which can be a little unnerving sometimes. And they did have a vested interest, though, in getting their drinking water supply back on. Sorry, terrible. As you've seen earlier on, it was known that we needed to remove the material at the spill origin. The ground around the spill was also contaminated with herbicide, but would have been impractical to remove everything. Therefore, interception recovery trenches were proposed. The old drainage needed to be flushed to remove the herbicide and the effluent recovered. Although initial removing of the effluent by tanker reduced the risk, it was necessary for the effluent from the drains and recovery trenches to be treated to reduce the cost of disposal. On the plan, the interception trenches are shown in yellow, just through here. You can also see the network of drainage that was discovered, and a number of the chambers were utilised for the ongoing recovery of herbicide. The main purpose of these works was to reduce the ongoing risk to the deeper underlying principal aquifer. The photo on the left shows the excavation for the interception trenches, and as you can see, it immediately filled with perched water, which gives you an indication of the volumes of water we were tackling. It's also quite remarkable that even with all the dilution, the concentration of herbicide remained a problem. Submersible pumps with float switches were used in both the trenches and drainage chambers to ensure the system could run with minimal contact over an extended period. The flow information was also important so that an adequate treatment system could be designed and operated without the risk of further pollution incidents as a result of insufficient capacity. The far right photo over here shows some of the broken drainage we identified during the investigation. It is in there somewhere. This was clearly one of the pathways for herbicide contaminated water to migrate into the deeper aquifer. You see the hole through the base of the chamber there. As discussed previously, a solution was required for the large volume of water and herbicide that was pumped from the drainage and shallow ground. In the early stages, we made use of a rapidly deployed fast tanks before moving on to permanent tanks. It was essential to have a sufficient storage of pumped water so as not to overload the treatment system, which required specific flow rates. The water flowed through a series of treatment processes to reduce the herbicide concentration and was then stored again and analysed to confirm the success of the system. Following a trial period, it was agreed with the Environment Agency, due to the success of the system, that the water could be used by the farm for irrigation. This proved to be a very cost-effective solution for reuse of the treated water. The system was finally decommissioned in 2018. After much sampling, testing and monitoring of the principal aquifer, there remained herbicide concentrations in excess of the UK drinking water standards. Obviously, this was not acceptable to the Environment Agency. A detailed quantitative risk assessment was essential, and given the extent of contamination, additional investigation was required to ensure the DQRA had the appropriate information. To try and bring closure to the investigation, the scope was prior agreed with the Environment Agency. In agreement with the EA, further boreholes were drilled to further refine the extent of the contamination and to monitor its movement. We analysed the data over a period of time to confirm the flow direction of groundwater and to monitor the attenuation of the contaminants. This additional site-specific data was absolutely essential for the DQRA. On this slide, you can just about make out that the boreholes were targeted on the areas where the contamination had been identified. So hopefully you can see that. The area of the impacted deeper principal aquifer, as a result of the drainage features, was used as a secondary contaminant source location for the purposes of the modelling. The works were made more complicated by the constraints of working in the vicinity of a high pressure fuel line, which required a standoff of 30 metres. And this significantly impacted on the area that needed investigating. You see it just marked through here, the high pressure line. So the spill, the pond was down here, and then very close proximity to the oil line. A conservative model was adopted, as that was considered the most likely to be accepted by the Environment Agency. Prosulfocarb was no longer a consideration, as that was not identified in the water samples. Lineron was also shown to attenuate after a controlled distance to below the UK drinking water standards. Unfortunately, metribuzin modelling showed it would remain above the UK drinking water standard. Consequently, additional research was undertaken into metribuzin and specific health criteria values proposed. The modelled attenuated values were below these new criteria values. This modelling was subsequently issued to the Environment Agency for review. This is the response from the agency, which as far as we're concerned is excellent. And as you can imagine, this was very well received by the client and shows the benefit of a practical and technical approach to spill cleanup. I won't read it out to you. In respect of further remediation of the principal aquifer, the agency agreed that there was little benefit in continuing. It should be noted that this small, simple spill of 1,000 litres has impacted on the viability of the aquifer as a resource, and a record is maintained by the agency should they receive future inquiries for abstractions. So in conclusion, emergency mitigation measures are still important. Not all spills require absorbance. Non-oil spills can be complex. Understanding your pollutant is essential. DQRAs are a vital tool with regards to groundwater pollution and liaising with the agency. And timeframes can be very, very long. Thank you very much for your time.
Great. I'm just going to unmute people, but Rory, I've just got a question. You've given us how long it took, but was there any issues accessing the neighbouring land? Because and did some of the neighbours require compensation for access to the land or taking their land out of use?
The compensation is an interesting question and probably not one I can answer immediately. But the access regarding the land, no. All the neighbouring landowners were farmers. They all had a vested interest in resolving the issue. Yeah. I think there was an added incentive of having the agency in the background, possibly saying that undertake the work regardless of permission given. But yeah. I think they were all fairly happy to resolve it. Good.
Now, has anybody else got any other questions? Now, I just, if you can, please push them through on chat, and I can ask them. But just another one which came to mind, you know, this was obviously quite a long project, and was the delay just in the amount of investigation required, or was it one where or was it just waiting for the agency to sign it off?
It didn't follow the normal process. The Environment Agency were very keen on remediation, and right up until very recently, that's what they were still insisting on. And it took us a long time to collate all the data that we required and all the additional toxicology information in order for us to demonstrate to them satisfactorily that there wasn't an ongoing risk. So that's where the time really came. And then there's subsequent validation, monitoring and sampling.
Okay, great. Well, Rory, thank you very much for that case study. I haven't had anybody come in on chat, so so I can take it that there's no more questions. But while if you can unshare your screen, I'll get back to sharing mine, and then there may be some questions arise. Okay. Well, I thought that was a really interesting case study, and thank you, Rory, for sharing that with us and for putting that together for us. That was really good.
No problem at all.
I haven't had any more questions come through, but if I can just flag up our next webinar, this will be in mid-November. It will be returning to a topic that we covered in September, which was the loss of the MV Wakashio. There's quite a lot has happened since. And what I want to do is to bring everyone up to date with what is going on with this significant spill and the loss of this vessel. We'll be hearing from an NGO on the ground. What we should be hearing from the spill response company who are managing the cleanup. And we'll have some other information about what steps were taken by the government once the Wakashio ended up on their pristine coral reef. What I can say is that there have been that the spill is still causing huge political, social, and environmental harm within Mauritius, and the government's competence has been questioned. The whole process of managing incidents has been questioned, and there is a lot which is going on behind the scenes with regard to it. So it's a very pertinent spill. And finally, I'd like to sort of say thank you very much for attending. We'll be emailing you asking for feedback. Please do. Now, if you want to contact RSK Raw, we will be sending Rory's details through. We'll also be emailing on any webinar and association matters. And if you don't want to hear from us, then opt out when you get the first e-news. Please follow us on www.ukspill.org and catch up on accreditation matters on www.isasaccreditation.org. Rory, thank you very much for a very interesting case study and for presenting it so well. And thank you very much indeed to all of you for attending. Thank you and have a good evening.
Thank you, Mark.
Thank you.